All right, so what we're going to do is we're going to take some of the multiplication problems that you've been given. We're multiplying by a one-digit factor. One factor is 3 digits, the other factor is 1 digit. Now I'm going to say this, and I want you to hear me, because some of you have told me, I'm not good at multiplication, I'm not good at division. Well, I need you to listen, and I need you to believe me. If you can read a multiplication...
I have it on Google Classroom.
Okay, stop talking, Kipton.
What?
Stop talking.
Why?
If...
Question that he needs to ask. Okay.
If you can do your 0 through 9, or you can read a multiplication chart 0 through 9, then it doesn't matter how big a number is, you can multiply it. It doesn't matter how big a number is, you can divide it. So if you stick with me for the next couple weeks, and we learn the steps to multiply, we're going to division next, and you're going to be experts at both of those things. Experts at both the multiplication and the division. But all you have to know is how to do your 1 through 9. That's it. If you don't have them memorized, you need to be able to look at a multiplication chart to do 1 through 9. Or be able to make a multiplication chart where you can know 1 through 9. Easy peasy, raw chicken squeezy. We're going to work on problem 12. 4 times 2,899. 4 times 2,899. First of all, I don't like my multiplication problems written horizontally. Now, when I have different types, I may want them written horizontally, but this I don't want written horizontally. I want it written vertically. I take my factor with the most digits, which is 2,899, and I multiply that by 4. So I have it written like this. 2,899 is a factor, 4 is a factor, and I'm looking for the product. But anytime before I do this, I'm going to make an estimate. And my estimate may be different than yours. I'm looking for an estimate so that when I look at this problem, I can do it in my head. You might be able to do different numbers in your head because your head is different than mine. But I want to be able to do this problem in my head first to give me an estimate. I'm not going to change my one-digit number because that's just ridiculous to change that because I can multiply by one-digit numbers very easily. But I'm going to change this to 3,000. I'm not saying I'm rounding. I'm not saying I'm doing anything else. I'm changing it to something that makes sense to me so that I can do it in my head. And I'm still going to multiply it by 4. Now, as I've said in the past, when I have zeros that are trailing behind a number, I have a whole number here, and they have zeros, I can really just bring those 3 zeros down. Why can I do that, you ask? Well, even if I multiplied it the correct way out, 4 times 0 is 0. 4 times 0 is 0. 4 times 0 is 0. I mean, it's just going to be that way, and it just saves me from having to do the times 0 is 0, times 0 is 0, times 0 is 0. That's just silly pants. I don't have to do it that way. Now, as I said, 1 digit times 1 digit. 4 times 3, which I know is 12. And so my answer should be near 12,000 when I do the correct, or when I do find the actual product of this problem. It's going to be less than 12,000 because I multiplied by something greater than this factor. I made that factor bigger. So if I get an answer greater than 12,000, that's a clue to me that I've done something incorrect when I did my actual math. 1 digit by 1 digit. I multiply my 4 by my 9. So I only need to know 4 times 9. If I don't know it, I can look at my multiplication chart, and 4 times 9 is 36, or 36 ones, so 6 ones and 3 tens, because I can only put 1 digit down here at a time. 4 times 9, again, same thing, 36, but then I have to add the 3 I have here, so that'll be 39. So 39 tens is 309 tens. Now I have to know 4 times 8, which is 32, plus 3 more, which is 35. So that's 35 hundredths, or 3 thousandths and 5 hundredths. 4 times 2 is 8, plus 3 is 11. So I got close to 12,000. In the same neighborhood. I made it over 100 greater over this, my estimate. This factor became 100 greater. So the more you change your numbers, the bigger the difference is going to be in your estimate and your actual product. But the whole time through, all I did was 1 digit by 1 digit at a time. You do not, and the rock means, do not have to do more than 1 digit at a time. You can only put 1 digit down here in the answer at a time. So just do it 1 digit at a time. Don't be all panicky. Don't be all panicky. That's cray-cray. Let's look at the problem that says 384 times 2. (384 times 2). First, I'm going to write it vertically, because that makes it easier for me. My larger factor, the one with the most digits, is going to be the top factor. My smaller factor, the one with the least digits, is going to be this bottom factor, bottom. First thing I do is I make an estimate of it so that in my mind it's easier to do. So I can make 384 to 400. 400 times 2 is easy, that's 800. Now I go over here. All I have to be able to do is multiply 1 digit numbers times 2. 2 times 4 is 8. 2 times 8 is 16. 2 times 3 is 6, plus 1 is 7. I'm going to say it again, and I'll probably say it 1,000 times between now and your 21st birthday, is if you can multiply a 1 digit number by a 1 digit number, you can do any multiplication and you can do any division. You can do any multiplication and you can do any division. I need you to put it in your head that you can. Don't tell me you can't, unless you say, I can't do that yet. But if you stick with me, you work, you have a question, you go back and watch these videos, you will be able to do this and get really good grades on it. Question